Okay, our second example in the 9.1 lecture, still solving using the square root property. Here we go, this is a good one. Quantity x plus 3 squared minus 49 equals 0. So we see it's a quadratic, right? We've got the square happening, and okay, it looks a little bit different, but all right. Our goal here is to solve for x. It turns out there will again be two answers when we're all said and done. So let's think here. How are we going to begin this question? What would the first step be? And well, we've seen these now a number of times, and even just the last example. We're going to begin by adding that 49, right? We're going to get this by itself. Turns out here, since this entire x plus 3 is in parentheses squared, that whole thing is what we want to isolate. We're going to get this by itself. Okay, let's see what that looks like here, right? It's just adding, well, I guess I rewrote the whole thing, and now I'm adding the 49, and we arrive at this. Okay, so once we have this squared equals 49, what might we do? Well, hey, let's go for it. There's the square. Let's take the square root to cancel that at this point. And so there we go. Our square root and our square are going to cancel out here. When I take the square root of 49, I recognize I need that plus or minus in front. So easy to forget the plus or minus on the number side. But yeah, we got to recognize we need the positive or negative version. And so the next line would be, well, here they cancel. We've got x plus 3. On the right side, that 49 comes out nicely. Plus or minus 7. Now, this one's going to wrap up a little bit differently than the last two problems that we've done. On the last two problems, taking the square root was the final step, and it just left us with x here on the left side. But this one's a little bit different because now we don't just have x only, we have x plus 3. So here's what we're going to do. We are going to write the two separate lines that stem from this one. We're going to say, hey, this really means x plus 3 equals 7, or x plus 3 equals negative 7. So let's write those two separate things, and then we can solve each of these and get our two answers. So if we subtract 3 here and we subtract 3 there, we've got x equals 4 as one possible answer, and on this side, x equals negative 10 as our answer on here. And so there's our two possibilities. But now, because of that plus 3, it's not just plus or minus the same value, two very different numbers. So there we go. If you're wondering, hey, could we check our answers? Is there a way to confirm and be 100% sure that we got an answer right? Yes, absolutely. We could take both of these numbers separately and put them back into the original, right? We could put them back into x. Hey, if x equals 4, would this all work out to be true? Now, if we check. Four plus 3 squared minus 49. Yeah, that's going to work because, well, that'll give us 7. 7 squared is 49. 49 minus 49. How about negative 10? Is that going to work out if we wanted to check? Well, that would be negative 7 when we add. When we square, it will be positive 49. And yep, this will work out just fine. So, on a test or something, we can be 100% sure that we got the answers and they work. You may be asking, hey, is it possible for these kind of questions for an answer to be extraneous, right? When we were solving radical equations, sometimes we thought we had maybe two answers, but it turned out only one was a real answer and the other one was like an imposter, that we called it an extraneous solution. That is possible in radical equations. However, in quadratic equations, there will never be an extraneous solution. All of the answers that we come to in the end are going to work. Now, we're checking here then not to see if either one of these is extraneous. We're checking just to see if we did all of our math correctly. Did we make a mistake someplace? So when we plug them in, we know it should work out if we got, there's no possibility of an extraneous here. And that's really nice, right? There's never an extraneous situation. Okay. So what I want to do, especially since we only had 2 videos for this lecture, at the bottom here, I'm giving you 2 problems. This is what I would have presented up on the projector if we were doing these in class together. I would have said, hey, take a look at these on your own. Part A, 5x squared plus 6 equals 86. And part B, 3 times the quantity q plus 5 squared minus 1 equals 8. So solve those using the square root property. And when we come back in the next video, we'll do both of those together. But yeah, take your time. Try to tackle both of these, and then you'll see the solutions in part 3.